Hi, I'm Wild Bill. It's the 16th of August, 2026. And I'm here to tell you today, on this tornadoes on the way day, that physics missed a spot. By now, string theory has been fairly well, I don't want to say debunked because the scales involved are too tiny for any testing to be done. But there are theories that fit most of the data, and these are the ones that are being developed and refined. However, string theorists, who are a subset of scientists commonly called cranks in the outside world, fringe theorists by the other fringe people like me, have come up with something which I think is incredibly relevant to this discussion as to what reality really is and where it comes from. I'm going to postulate a situation. You're welcome to shoot it down anytime you like. I'm going to postulate that strings exist. A string is an expression of the basal tension, the Planck basal tension. At the very smallest scales of the universe, which we can't reach or test. The universe is textured. And in those tiny little corrugations of the universe are stored the energy budget of the universe. So any work that gets done, any effect that happens, any particle, any force carrying, anything that takes place in the universe does so through the employment of the energy of this Planck basal tension. As you use the energy, that piece of the basal tension starts to relax slightly until eventually the uniform will be planiform with no distortions and no energy to distribute anymore. That's the ultimate expression of law, and that's why chaos hates law. Everything the same, no good bar to hang at, no bar where at least today his air conditioning is working. It doesn't happen in a perfect universe. Okay, so what if these strings do exist? It's an effect, an artifact of the shifting of the Planck basal tension, which takes place all the time. We have what we call vacuum energy. We have also, I can't think of the name of the postulate, but it's been recently shown that vacuum hates, the universe hates a vacuum. So even in places where the particle density is so incredibly low that we can reliably do vacuum experiments in it, that virtual particles, things that are just there momentarily, bookkeeping particles, just kind of like flare into and out of existence constantly. White noise. The background of your physics microphone. What if the string exists? It's a tiny little zigzag at a scale so small that I don't have the numbers for it. It vibrates in a number of dimensions. These give rise to macro universe effects. That's a lot of basic string theory. That's the concept behind string theory, which is very mathematical and I'm not, so I'm good with the concept. Now, if that string does contain all the, I'm going to call it information, but it's really energy density, all the information needed to manifest quarks and gluons and thus all the inference, nucleons, atoms, all the matter that we know, and all the dark matter we don't. They must contain, these strings, an incredible amount of energy. I'm not sure if at that level you call it binding energy anymore, but it is potential to manifest. So it is energy that's most fundamental. If a string contains that much energy bound up in this minuscule object, because it's a non-point. This is the important part about string theory, is that all of physics ignores the fact that there is no single point, and the idea of a singularity flies in the face of what physics had told us all those years. There is a major change in perspective, and nobody talked about it because they want to make it look like an unbroken chain of advancement, which it is not. So this string particle, miniature particle, tiny little thing, is not just vibrating, or perhaps instead of vibrating, because I'm postulating a difference in what they usually view the string as. What if it's rotating? What if it's rotating fast? When I say fast, I mean relativistically fast. If you move up the scale, and the farther up the scale you move, of course, the slower things move. But the farther up the scale you go, you get, let's say, a nucleus, oxygen nucleus or something. Each of those nuclei composed of nucleons, individual protons and neutrons, and of course the binding energy between them and the various force carriers, is part of what seems to be an alpha particle, 2 protons and 2 neutrons. And there are a bunch of these in the oxygen, 4 of them, right, in the oxygens. 8. So there are 4 of these in the oxygen nucleus. And they aren't sitting there. They are rotating, and they are interplaying at 40 to 60% of the speed of light. Look at Einstein's equations, where he elegantly says energy and mass are the same. That's what we're talking. We're talking about this incredible amount of energy, unbelievable amount of energy, in the string, implicit in the string. Well, if you have something that is that energy dense, it also acts as if it is that mass dense. It is an incredibly super dense object as well. So, like, stars are not very concentrated except near their cores where they're pretty dense, right? But neutron stars are even denser. And what we call a black hole is even more dense. Scientists use this prohibited word over and over again like it's meaningful, which it isn't. If they're scientists in infinite, they say infinite. Which means, in science terms, they just said God. Because there's no infinity in science. You physicists, tell me. Okay. So anyway, this string has that much fundamental energy in it, that much ability to affect, to create, to promote, to manifest effects in the larger world, the larger universe, our perspective. And it's spinning. If the nucleons in an atom, which are far larger, are spinning inside the nucleus at 40 to 60% of the speed of light, how fast do you think that string might spin? Well, it is the fundamental object of the universe. It will have the highest spin of all objects. That's metaphysics, but I think scientifically it can be spin. So that means it's doing something that we see in larger effects. It's frame dragging space-time. Hello, my scientist friends. As it does, that means that reality is trying to curve to match the motion of the string as it spins at relativistic speeds, or perhaps super relativistic. This is outside the rules that we have to obey. So it might be instantaneous causality. Ooh, there's another one of those words you're not allowed to use in science, but when they do, everybody goes, oh. So, at any rate, propagation of change instantaneously is also impossible as far as we know in science. Even quantum entanglement does not allow for transmission of data beyond the speed of light. That's just this trap we're caught in. But down below, and also an expansion of the universe itself, which is considered outside the universe for some reason, it's allowed to move as fast as it wants. Light is no barrier. So, as this string, this tiny, infinitely small, this close to infinitely small string, right, which is basically an expression of the energy budget of the universe expressed in textured space. As this spins, it frame drags. Everything tries to catch up with it and can't, and lags behind. That creates resonances in space-time, just like the resonances on a guitar string. It's like the harmonics on the 12th fret. And these harmonics interact and form, in music would be chords. In physics, it's quantum fields. Quantum fields arise from frame dragging resonance caused by string relativistic rotation. Wow, Bill, a fringe science doctoral thesis. Haha. I must think I'm smart. And we all know when a person thinks they're smart, yeah, probably not. But it does please me wildly to be able to like come up with ideas that I haven't read somewhere else. Thank you. If you listen to this, wow, you're cool. I mean, really, you're cooler than I am. But thank you very much. Here on the 16th of August, 2026, frame dragging gives rise to quantum